your pocket right now, you have a device more powerful than the computer that took humans to the moon. So how did NASA pull that off in 1969? No touchscreen, no internet, less computing power than a calculator. Did we really land on the moon without modern computers? This question shows up everywhere, especially in arguments that claim the moon landing couldn't have happened. And to be fair, at first glance, it sounds reasonable. Apollo 11 had to launch from Earth, travel almost 400,000 kilometers through space, enter lunar orbit, land on an uneven surface, take off again, and return safely. All of that with technology that looks painfully primitive by today's standards. So let's clear this up properly. Yes, we really did land on the moon. And yes, we did it without modern computers. But the way it worked is very different from what most people imagine. The computer used during the Apollo missions was called the Apollo Guidance Computer. By today's standards, it was incredibly weak. It had about 64 kilobytes of memory and ran at roughly 1 megahertz. Your phone is millions of times more powerful. Even a cheap calculator can outperform it in some tasks. So how could that tiny computer possibly guide a spacecraft to the moon? The answer is, it didn't do everything. Not even close. Apollo missions were not automated in the way modern spacecraft are. The computer wasn't there to think. It was there to assist. The astronauts were the ones making decisions, monitoring systems, and reacting to unexpected situations. The computer handled specific calculations, kept track of position and velocity, and helped with guidance and timing. Think of it less as a brain and more as a very fast, extremely reliable calculator. And that simplicity was intentional. NASA didn't want powerful systems. They wanted systems that would not fail. Complex computers crash, they glitch, they behave unpredictably. In space, that's unacceptable. So engineers designed the Apollo computer to do very few things, but to do them perfectly, every single time. Even the software was different from anything we use today. It wasn't stored on a hard drive or a disk. It was physically woven into memory by hand, using wires threaded through tiny magnetic rings. The pattern of the wires represented the code itself. Once it was made, it couldn't be accidentally erased or corrupted. If the computer lost power, the software was still there, unchanged. And here's something almost no one talks about. Much of this software was literally hand-woven by teams of engineers and technicians, many of them women, who translated lines of code into physical patterns of wire. That's how critical the software was. It wasn't just written, it was built. Now let's jump to the most famous moment of all, the landing. As Apollo 11 was descending toward the lunar surface, alarms started going off. Error codes appeared on the computer. This is often presented as proof that the system was failing. But the opposite is true. The computer was doing exactly what it was designed to do. It recognized that it was overloaded with tasks, so it started dropping non-essential calculations and focused only on what mattered most, keeping the spacecraft stable and guiding it toward the surface. It didn't crash, it didn't freeze, it prioritized. Meanwhile, Mission Control on Earth analyzed the alarms in real time and gave the go-ahead to continue. And then something even more important happened. Neil Armstrong looked out the window and realized the computer was guiding them toward a rocky area that wasn't safe to land on. So he took manual control. Using his training and judgment, he flew the spacecraft forward and landed in a safer spot, with only seconds of fuel left. The computer didn't land the spacecraft. A human did. This is where many conspiracy theories fall apart. They imagine a Hollywood-style mission run entirely by machines, where one weak computer would make the entire thing impossible. But that's not how Apollo worked. It was a collaboration between humans and machines, where humans were always in charge. And if this had all been fake, the hoax would have had to be perfect. Thousands of scientists, engineers, and astronauts would have had to stay silent. The Soviet Union, America's biggest rival at the time, would have had to play along. Moon rocks studied all over the world would have to be fake. Laser reflectors placed on the moon, still used today to measure the distance between Earth and the moon, would have to be explained away. Faking the moon landing would have been harder than actually doing it. The real lesson of Apollo isn't that computers don't matter. It's that understanding matters more. NASA didn't rely on raw computing power. They relied on physics, mathematics, redundancy, careful design, and people who deeply understood the systems they were working with. We didn't go to the moon because our computers were powerful. We went because our thinking was. And maybe that's the most unbelievable part of the story.